Good evening, ladies and gentlemen. Welcome to DC1 and thanks for tuning in for April's monthly update on the HX50 development program. We're trialing a new format tonight to try and keep it as punchy and focused as we possibly can. Do let us know what you think and we'll take that into consideration in time for next month. Let's start with some good news. After a successful Heli Expo show, our two aircraft have finally cleared customs and are on their way back to us. We continue to enjoy very strong sales, so our current sales figures are 919 X models and 370 Cs, a total of 1,289 aircraft in total. We've had a big push on a number of commercial areas in the business over the course of the last month, particularly recruitment. We're massively expanding our development team now to support the final push towards production and the certification and approvals program across the range of countries that we've got to execute that in a very short period of time. So if you're interested in working for us, do have a look at the website and come and talk to us. The main focus of this evening's update is going to be on the development of the GT50 engine and the development of our PC1 production facility. Let's get stuck in. So let's talk about combustion testing. This is our combustion test rig, and as you'll recall from last month, we got a rig together and we'd done some preliminary trials showing that we could get ignition, we could get stable combustion, and we could run that through the startup phase of the engine operation. During that testing, we determined that there were a number of characteristics of the combustion process that weren't quite optimal. The combustion flame angle, the cone, was too wide and it was impinging on the combustion liner. So we needed to adjust that to make sure that we get the life out of the combustion liner that we need for GT50. In addition to that, we'd noticed some inhomogeneity around the cone, which indicated that we weren't getting uniform flow where we should be. We've done a bunch more analysis and identified what the causes of that were. In addition to that, we've made a bunch of upgrades to the rig itself. So we've now got a much larger blower to enable us to run through a much wider range of operating conditions. We've got a whole host of new instrumentation to be able to interrogate the findings and the test readings as we go through the process. A bunch of improved controls so that we can automatically control and instrument the whole execution of the test. And importantly, the things that we really needed to modify were the key characteristics of the development swirler and the development nozzle. So this is much bigger than the actual one that we'll put in the engine. We've made it simple for ourselves to be able to conduct the tests, but we have a nozzle in the center and then a swirling body of air comes out to help contain the flame as it burns and prevent it from hitting the side of the casing. So what we've done since we last spoke to you about combustion is essentially we've modified this assembly so that we've broken the swirler body into separate components. So we can now actively change the swirler angle and the key driving geometry of the swirl. So we can change the angle of swirl, we can change the mass flow going through the swirl live on test. So within 5 minutes we can update the way the swirler operates and truly optimize that for the whole range of operating conditions that we need for the GT50 engine. So we've done all of that. We've got the new swirling components manufactured. So an interesting point with this, there's a big move in industry at the moment to go and produce things using 3D printing to rapid prototype. It's actually the case that we can produce updated swirler components right here using conventional methods faster than we can send them out to a bureau and get the parts made. So these updated swirler components are made from the right material right here at DC1, and that's allowed us to rattle through some test iterations on the updated nozzle and swirler geometry much faster than we would have otherwise been able to do. And what a difference a month makes. Have a look at this for the latest test results that happened earlier this evening. So in the early trials, we had a very fragile and sort of chaotic flame that was far too open in the cone angle, impinged on the outer liners. And what you can see here is we've now got the striking, strong, stable blue flame. The cone's still a little bit too open, but we're going to adjust the swirler geometry using the kit of parts that we've got here to bring that back in, keep that flame front away from the combustion liner, and develop that strong, stable flame that we need to give GT50 the performance that it needs. Immediate next steps then, we're going to get the swirler updated to bring that cone in. Then we can do some further work on the nozzle itself and just make sure we've got the full range of operating conditions and good atomization so that we can relight at altitude. And then all of the learnings from this go straight into the full combustor and get ready for the gas generator test. Really pleased with the progress on this. So the other key area of GT50 that's been developing at pace is our direct drive starter generator, the MGU unit, and its PMU control unit as well. Last month we updated you that all of the core internal components for the motor, the rotor and the stator parts had been produced or were in production. Over the course of the last month we finalised all of the interface components with the engine itself. So the casing, the sealing plates, the drive shaft that mounts the rotor itself, and the various other bits and pieces that go with it to complete the GT50 engine. All of those components have been released to production, and Mark and the team are now busily producing those. So very shortly we'll have a full set of 5 starter generator units to test. Now, in terms of the testing, our test facility has now completed its acceptance testing over with the manufacturer. So this is the high-speed test unit that will allow us to drive the generator as a generator, and will also allow us to drive a rotating load when it's operating in motor mode, all the way through its operating range from 0 up to 50,000 RPM. That kit is now on its way to us. We had a couple of minor balancing issues to resolve, which we've subsequently done, but the kit is now ready to be sent over to us, and we'll have that installed in PC1, ready for PC1's opening. So let's talk about the digital cockpit for a bit. We had a lot of really positive and constructive feedback from the 2 machines being exhibited at Duxford and then at Heli Expo, and we've been trialling some of the concepts, some ideas based on that feedback over the course of the last month. One of the crucial areas with helicopters, of course, is the vertical speed indicator, and as a helicopter pilot we're predominantly interested in the low rates of vertical descent associated with avoiding vortex ring state. The problem being, of course, if you look at an implementation on either a traditional analog or most contemporary vertical speed indicators, the rates that we're interested in are actually very, very small on the overall scale, because typical helicopters can climb and descend at about 2,000 feet per minute. So one of the things that we've been trialing is looking at creating a non-linear range for the vertical speed indicator so that we can expand that crucial range close to the critical zone. Eric, why don't you take us through what you've been developing?
Sure. So we have a very early concept of a nonlinear VSI, and so I've just switched over to it now here. And basically you can see, so the value hasn't changed. So before it was right there, and if I switch it over, you see that the needle, the size and the amount of space and I guess granularity you have to be able to read the gauge at those areas closer to neutral, you have a lot more information that you can glean from it.
Yeah.
Now, of course, the drawback from it is that it's nonlinear, and so when you're flying and when you are changing your vertical speed, then the needle moves, even though you might be accelerating at a linear rate, or
the needle will
accelerate. The needle will accelerate, right? So I can illustrate that here. If I turn the simulator on, you can see the needle slowing down when it's up on the edges, because that's where the kind of curve tapers off, but then it goes quickly through the center range.
Through that range.
Right. So this is a very exaggerated sort of concept, but it was an early concept to just kind of test the idea. I think there's value in it, but I think we need to maybe flatten out the curve in the middle range, and then kind of curb it off on the edges.
Just soften the response so people don't end up overreacting.
But overall, I think it's an interesting idea and has potential value.
Fantastic.
So we'll keep moving on that.
Great. Talk to me about airspeed. So at the end of last year, we moved the airspeed from the bottom to the top to improve the instrument scan and to keep it closer to your eye line while you're flying. That's worked really well. But we've had lots of feedback that you still don't quite get the sense of rate of change of airspeed with just the progress bar. Tell us about some of the options that you've been exploring off the back of some of the feedback.
Yeah, so the progress bar gives you, it does give you rate of change, and it does give you a kind of a positional reference. You do get some value at a glance. However, it's not quite as clear as a dial where you have an angle. When you look at the altitude and you see the needle straight up, you know you're going to be some multiple of 1,000, right? Or if it's straight down, 500, right? And so you don't get that with the airspeed. You don't have as much of a positional reference with just a progress bar. So I'm just going to switch this airspeed indicator over. All right, so I've just switched it over to this new concept, which is essentially an elliptical arc for the path that a needle follows. And it's very early stages, very rough. Still needs to go through the fashion department in a sense to get it cleaned up and refined. But if I just get things moving here, you can see that you have more of an angular change similar to a dial, and you have a little bit of a better glance value. And this is without any colors or arcs or gradients and that sort of thing. This is just the scale and the needle, and already I think it is somewhat of an improvement. So some ways to go on this, a lot of refinements, but this is, the benefit of having a simulator. We can do very quick iterations with some of these concepts to test it out.
And don't forget, what we're trying to do here is fuse the best of old analog dials with what a digital cockpit can offer, and that's precisely what we're doing here. That's great stuff. So one of the things that you've also been doing over the course of last month is to take a tablet-based implementation of the DigiCockpit hardware. So our screens coated, backlit with our processes, our DigiCockpit implemented on there, driven by our graphics boards, and take those, sit that on your lap in another aircraft and go flying with it and have a look at how these screens perform during normal flight operations. So why don't you tell us a little bit about that? Firstly, how did the screens perform?
Yeah, the screens performed great. The brightness ranges were acceptable with both the high end and the low end for making sure it's bright enough in the day and dim enough at night. The glare and the reflections were good with the coatings. I was happy with that. And this general size and the position relative to the eye point and the readability of everything, it all passed the test.
So font sizes and contrast, all good, easy to read.
Yeah, there were definitely some areas where we learned. For example, my assumption going into this was that the highest contrast areas, as in like as bright for the text for the foreground and as dark for the background to obtain the highest contrast, that would result in the best readability. But the takeaway was that isn't always the case, because if there's reflections, you see the reflections more in the dark areas. And so it's actually better sometimes to have a brighter background, reducing contrast essentially, but better readability because you don't see as much of the reflections.
Fantastic. And so that's great, and that worked really well during the daytime. Reflections were well managed by the coatings. How about your ability to actually use the touch screen when you're bouncing around in a helicopter? Although the majority of stuff will be done on the IPI, was the big touch screen still usable in practice?
Yeah, it's still usable, especially since we're planning on having a rest where you can rest your hand so that you don't have your whole arm moving around. You can rest your hand and then touch, and all of the touch regions are intentionally placed. All the main touch regions are placed either on the bottom or the left edges of the screen, so you can rest your hand on there and touch with your finger.
Fantastic. So one of the things that we haven't showcased yet that we also tested during those trials is our night theme. So obviously the very bright, high contrast stuff is necessary during the day, but at night that's somewhat overwhelming, as you demonstrated during the trials. What have we done about that?
Yeah, so at night this color scheme is too bright, especially with the artificial horizon and some of these bright highlights. And so we're experimenting with the concept of having more of a dark theme, dark mode, where the the bright areas are reduced. There's less contrast. Everything's fully readable and clear, but it's just not quite as bright for use in night flying, and that's been a success. These are just some early concepts here that I'll flick through. It's all just in the design stage at this point, but
and of course it looks great, but unfortunately you can't use that during the day because it's too dark during the day, isn't it? So you'd just be dominated by external reflections.
Yeah, I think you might potentially be able to use it during the day, but it's not as good. Not as good for the reason I described of the very dark background with it. You see more of the reflections. So, but on the reflections, I want to note that the coatings we have in this laser were excellent, and so it's really not that much of a problem. You just see it's all blurred out, and it does a really good job at that.
So it's working as designed.
Yes. Yeah.
Fantastic. So this was also your first time flying with one of our 15.6-inch screens on your lap in the right position relative to its mounting in HX50. Now, one of the concerns that we sometimes get from customers and prospects is the fact that that's a big blockage right where you need to see. Did you do any confined area work, and have you seen whether or not this is going to be a problem?
So we have some concerns with, especially the final stages of confined area approaches where you have a really steep angle, and you do have an obstruction there. There's no way to avoid it. So we have some more tests we want to conduct, with also some additions of some pass-through through cameras, having a camera in the nose looking forward and down, that you have that feed coming through in the display. That would help.
So just use that as a background to the instruments.
Yeah, but by and large, the obstruction wasn't an issue for all modes of flight except for that high angle approach.
Yeah.
But the camera hopefully will add some visibility in that range.
And we'll be talking later about some of the lighting trials. We spoke earlier about some of the lighting trials that we've been doing for the external lighting system for HX50. One of the other threads that you've been developing, of course, is the use of enhanced vision systems as backgrounds for DigiCockpit. Do you want to just let us know where you're up to with that?
Sure. We've got some candidates for some infrared cameras, night vision cameras that we can use to basically do essentially the same thing, a pass-through feed onto display, just with a camera that works at night, right?
Yeah.
And so the idea is, can we improve the situational awareness and safety of the pilot at night flying by giving you at least some indication when you're high up and you say you have an engine failure and you need to identify a place to land, you need to have some way of choosing a suitable direction to go for a landing spot. And most of the time in VFR night flying, you don't have that. You just see blackness, right?
Yeah.
And so with some sort of infrared camera, you might get some of that texture where you can distinguish between a field and a forest, which you wouldn't otherwise be able to.
Fantastic. So one of the final things that you've been looking at over the course of the last month is a minor rework of the stick heads on the Cycling Collective. Now, for the majority of people, they'll be aware there's things like landing lights, hydraulic switches that will always have to be on the stick heads. But the way we'd arranged the original button packs on here, plus and minus for frequency presets and a flip mode, all those things are really predisposed on how radios and things used to work. Yeah. So just talk about some of the things that we're looking to experiment with on the stick heads to better interact with a truly modern VFR digital cockpit.
Sure. So, like you said, some of these switches, we're still trying to assess the value of them. Some of them are very clearly valuable, like the frequency swap button and like autopilot off and that sort of thing is important. But like the plus and minus buttons, we're still trying to assess whether those are actually going to be valuable. We might switch them out for something that has more value. One idea we had was having like an Alt key similar to what you have on a keyboard, which would engage an alternate palette on the UI in certain areas for you to get to
like shortcuts.
Like shortcuts, basically, and alternate functions. So that's just one idea. So we're looking at options and trying to figure out the best way that we can use that space and use that instant access with your thumb or whatever, with fingers on the controls to do certain functions.
Fantastic. Thank you very much, that's great. So that brings us up to date with the DigiCockpit developments. Let's head over to PC1 and see how our latest production facility is shaping up. Another big focus of our attention over the course of last month has been our preparation to move into PC1. Clearly, there's a great deal of work involved in pulling out all of the facilities from DC1, DC2 and DC3, and then carrying out the vast amount of enabling works that we need to do in this brand new unit here, PC1. So if I just take you through some of the things that we've been dealing with over the course of the last month or so, the big one being the brand new machine foundation for our gantry mill. The gantry mill is the new facility that we're building to support our next generation composite manufacturing facility. This is the machine that's going to build all of the composite patterns, all of the composite molds, and a lot of the crucial tooling for all of the composite work within the company, not to mention trimming final fuselage assemblies and also trimming all of our polycarbonate and acrylic window panels. So this machine is crucial both to the remainder of development, but also to our production facilities as well. So in order to get the gantry mill installed here at PC1, then we've had to excavate a 14 by 15 meter base out of the one corner of the facility, remove the standard factory floor slab, excavate down, remove all of that material, and then build a 750 millimeter deep bespoke designed machine foundation. And the purpose of this is to physically hold the machine rigidly enough that over the span of that 15 meter base, it's able to maintain enough rigidity and stiffness to hold the tight tolerances that we need to produce patterns, molds and parts to extremely tight tolerances over these vast distances. So once we'd excavated the base, all of the new rebar's gone in, all of the new concrete's been poured, we've set the new base, and then just at the moment we've got the sealant going off ahead of the rest of the floor being coated over the next few days. In order to get PC1 ready for production, there's much more to do than just getting the big machine bases in place and the various other enabling works that we need to do. Before we can really move any of our infrastructure in here, we need to get even things down to the floor just right for precision engineering and manufacturing. Over the course of the last few days, we've had our flooring contractors in here shot blasting the whole floor. We've got to wait for the dust to settle, and then over the course of next week, the whole floor area will receive a high-grade epoxy coating so that we've got a clean and easy to clean surface on which to be able to carry out aerospace grade manufacturing. So with the new gantry mill's machine tool base cast down into the ground, with the whole factory floor coatings going down over the course of the next week, we'll be shortly starting to install the gantry mill. That happens around the middle of next month. But as you remember from the gantry mill work you've seen us do at DC2, this is an incredibly dusty process, working in materials like carbon fiber, the carbon dust, the model board dust, and trimming all of those sort of pattern making, pattern building materials creates huge amounts of fine dusts that have to be properly controlled. The new gantry mill is a fully contained environment, so none of that dust can escape into the broader production facility. And in order to then keep the internals of the gantry mill clear of dust and to process all of that, we're installing a industrial scale extraction unit from the machine outside. So let's go and have a look at the machine base that we've put in out here, just so that we can get that stuff installed also. So all of the dust is extracted from the volume of the machine, brought out through the factory wall, and then on this new concrete pad that we've installed here, we've got a unit that collects and compacts and then essentially palletizes all of the waste material ready for responsible disposal afterwards. So all of these little details have to be done before we can get into PC1. So all of the other fun things that Mark, Bruce and the PC1 development team have been getting on with over the course of the last month, all of the other crucial enabling works that we need to complete to be able to get into production here at PC1. So one of the key tasks that we have to get done first, of course, is routing all of the electrical power around the production facility. When you take possession of a new building like this, the power comes into the building, but that's about it. It's up to us then to lay out our manufacturing facility and route all of the crucial crucial services around the building that we need to. So over the course of the last month, the guys have been laying out the proposed factory layout, the proposed test rig layout, and all of the things that we've got in store for PC1, and then routing the critical infrastructure like the cable trays, the switch gear, the sockets, and all of the other infrastructure that we need, the local distribution boards and things, getting those installed in here, ready to receive the machine tools. Similarly, we've had to install our own bespoke lighting to suit our specific applications. So we've got half of the lighting in the port side of PC1 at the moment. The rest will be going in over the next couple of weeks. We've had to install compressed air, so the compressors are being moved over here next week, and we're getting the compressed air lines and all the control circuitry for that installed around the building. And then once we've done that, we then into the install of the mezzanine floor. So if you remember from when we developed DC1, then it's vital that our machine shops are temperature controlled. If you're going to hit the kinds of tolerances that you need to be able to produce gears and bearings, then we have to hold the machines, the materials, and everything in that process at really tightly controlled temperatures. Now, in order to avoid having to temperature control the whole facility where it's not needed, we're building a mezzanine floor over the machine shop. So the mezzanine floor has now been designed, and that's scheduled for installation over the next month or so. That then provides a lower level roof where we can install the climate control system that we're bringing with us from DC1. The climate control system has now been removed from DC1 and is in transit over here. That will be installed in the mezzanine section that's being added at the moment, along with all of the necessary fireproofing, lighting, and other containment systems we need to keep that machine shop under the precisely controlled conditions that we absolutely need to produce high quality, precision aerospace parts.